Oh, hello, can you hear me? Oh, well, I guess.
Oh, yes, sir.
Yeah. So I was just saying, I'm sorry for the delay there. I was attending some postgraduate oral exams. All right, so today I thought would start our discussion of lecture series number 15, right? But I mean, there's a couple of announcements, I guess, before we start lecture series number 15. And I don't want us to drag this. I mean, we just, well, I guess we'll see how far we can go here. But the plan is, as I mentioned last time, the plan is to hopefully just try and wrap up our discussion on lecture series number 15, preferably by Monday or something. If we do happen to have class on Sunday, I'm uncertain about Sunday because I'm supposed to be working from out of town. I think I'll be traveling on Sunday. But if it so happens that I get to my destination before 14, then we're definitely going to have class. I hope there's internet access. I think so. All right. So just a few announcements before we start here. And also, I don't think this is in the announcement here. We're supposed to, I'm thinking we use, I'm planning we use Sunday, I guess, because Saturday is a holiday apparently, right? Independence Day. Hey, guys, there's a, did you know there's a Grey Zulu exhibit on Sunday, right? So if you are into that, you should be actually. You might want to, it's free. It's at the Lusaka National Museum here. I do encourage you to go there. It'd be nice, right? Go and see how this exhibit is being. Who knows? Maybe this exhibit is not making optimal use of ICTs, and so you could think of interesting ways in which you can. I guess you can. Just copy it here. Optimal ways in which you can perhaps try and make the exhibit better than it's going to be. I won't be surprised if this will just be still images, because apparently this. The Grey Zulu family has this trove of images, right, of Grey Zulu, right? And there we go. So Saturday is a holiday. Instead of drinking, go to the museum. Great. So I was thinking we use Sunday, if we do have class, to just do a rundown, a walkthrough of the previous assessments that we've had, seeing as we've wrapped up lecture series number 14, so that in case people have any questions or need clarification on any aspects of what we did, then they'll have the opportunity to do that. So we do that on Sunday, right? But tomorrow we continue our discussion on latest quiz number 15. So just a few announcements here, right? And I guess we'll start with quiz number 14, right? Shocking, really shocking. I don't know what's happening here, right? Clearly there's a problem that needs to be fixed here. I haven't quite figured out what the problem is, and it's worrying here because if we've gotten to this stage and we haven't quite figured out what the problem is, then I don't know, right? And my worry here, right? My concern here is that the performance is depressingly low, irrespective of the fact that you guys actually have access to calculators. I don't understand. I fail to understand what's going on here. I fail to understand why only 18 people should be passing at this stage. I don't know. I don't know if people have any thoughts on why this is happening here, right? This very gloomy picture here where you have a huge chunk of the class, more than 50% clearly, right? 72% here, more than 50% of the class failing or getting below 4.5. Why? Why? And I know what you're going to, whoa, time. Come on, really? Are you going to bring up the time argument again? I don't think so. I think that the problem is you're not investing the amount of time that needs to be invested into all of this so that you understand. If you think, and I see you, a huge chunk of you will start accessing those videos, the recorded videos, on the day of the assessment. Do you honestly expect to get good grades if you do that? It doesn't work like that. Now, it might work like that for some individuals that are quote unquote gifted, but if you think that you can game this by I guess what we used to call it gunning or something, you are reading on the day of the assessment, you're making a very big mistake. I have told you time and again, the best approach to all of this is every time you have class, Use that same day to go through the materials introduced in class, so that at the very least you identify gray areas. Now, no pun intended, gray zone and gray areas. You identify areas that will require your attention. Do you understand this? Reading this a day before the test or a day before the quiz is not going to work. This is why you're getting these pathetic scores here. You're simply not studying, right? Now, also, I know, right? I mean, there are probably those of you in here that have figured out that, oh, you can use online calculators. Maybe that's why you're getting A pluses and A's. That's fine. I guess, I mean, it's technically speaking, it's an open book exam. It's not like you signed an honor code of sorts. It'd be nice if we could make you sign an honor code, although, I mean, in our culture, I don't know how many people take that seriously, right? But my advice to you is, if you continue doing that without really understanding what needs to be done, you're going to find it extremely difficult in the final exam. The final exam, by the way, is out of 50%, right? You're going to find it extremely difficult in the final exam because these questions are going to come in the final exam. You need to understand. The other reason you need to understand is that these things, some of these things are coming back next year. They're coming back in third year. They're coming back in fourth year. They're going to come back once you go out there and start working, for the vast majority of you. It's not that hard to understand. All you have to do, if you want to understand this course, this is just, I'll let you in a little secret here, right? All you have to do, if you wish to understand, and I guess it's too late now, but it's still time, it's never too late. All you need to do if you wish to understand ICT 1110 is show up for class or play back the recorded sessions and study, read, and understand. Every one of these lectures that I shared with you, there's a reason. It's not like I guess I also try and show off my aesthetic skills here. I'm pretty good at creating slides here. Please rate me, right? I'm sure I'm probably one of the best people when it comes to creating slides here. Consistency, and look at this, it looks nice. Every one of these slides, at the end, there's this thing that's called a bibliography. It's there for a reason. We understand that there is a wealth of information available out there, and so it's very easy for you to get lost in the mess and the chaos. This is meant to guide you on what you need to go and read, at least spend time on either one of these resources. The other thing is, the things you find towards the end here in the bibliography section are the things that are used as a basis to create these slides. It's not like I sleep and I dream about, oh, slide number 68 is going to have this thing here. No, well, sometimes I make things up, I guess, but there is material that is referenced to create these slides. So for you to be able to understand aspects of these slides that do not make sense, you go to these resources here. The only way you'll be able to manage to read through these resources is if you allocate time for ICT 1110, something that you're clearly not doing. And you're not doing this, we know you're not doing this because of this picture here, this sad picture here, this. I mean, what other explanation is there? Oh, I guess maybe I'm not effective at teaching. Maybe, I mean, there's only one way to find out. I mean, we can do an experiment next year and have somebody else teach this thing, right? But I don't think so. Or we can have somebody play back the recorded lecture sessions and ask them, do you think that this person, by playing back this lecture record, do you think this person was effective? I like to think I try to ensure that you understand this. But I think you're not putting in the effort that is required for you to be able to get good grades here. This is very worrying for me, right? It is very worrying that that people are failing to evaluate 2020 plus 4, right? 2024, convert that to using one's complement. Really? Convert that using sign magnitude. How hard is that? Right? You look at a range. In fact, the range that came in the assessment is literally based on the example that was in the slides in lecture series number 14. That range. How hard is that? what is the, I'm going to pause here for a short while here. And I guess I'll pause on this really sad distribution here. No, normal bell curve is no insight here, but I'm going to pause here and ask, what exactly is the problem? Are you there?
Yes, sir.
Yeah. So what's the problem then?
Sir, I think time is the problem.
Sorry? What's the problem?
I was saying time. Time is sort of the problem.
No.
I mean, it's always a problem.
Yeah. So here's the thing, right? Part of what in one of my responses, I don't know if you people even bother to read through those email threads when I'm responding to people, right? Even though I'm responding to specific people, I'll say, hello, Kennedy, but that message is meant for everybody, which is why I'm sending it to the mailing list. Kennedy is one of those people who raised the issue of time. And I reminded him that part of what we're doing here is training you to get used to this. One of the things you have to learn, if you haven't figured this one out, is once you pass through the questions, identify which questions you need to start with first. And there's different techniques that people use, right? I mean, you've written exams in the past before, so I'm sure you figured out what works best for you. But the approach I advocate for is start with low-hanging fruit, easy marks, or easy questions. If you're one of those people who is certain on the fact that you understand everything there is in question number lecture series number 14, what you would do then is you start with questions that have more marks so that you get the maximum possible marks. There will never be enough time, I assure you. All right? I mean, we can increase the time here for the quiz, but you still complain about the time here. You know, for certain topics, what we're expecting is that you teach yourself how to use these calculators you're going to use in the final exam. You are coming back very, very soon. Come and write the exams. I don't know if you've seen the most recent memo where they're inviting third-year students in the School of Law. Very, very soon, it will be third-year students in the School of Education, the first year, second years, and then boom, it's exam time, right? So before that time comes, you want to make sure that you understand these things. What else is the issue here besides the issue that Thelma was raising about time here? I see there's only 17 people in there. This is the other problem here, only 17 people around. What is the issue here? Kapala, what is the problem?
So,
Yes.
and I think, like Thelma said, I think sometimes due to time, when we are trying to go through to check on our mistakes, the quiz closes like that. Like what happened today in the morning, I missed most of the questions, and I got most of the questions wrong because I either missed a 1 or a 0 or a negative sign. So in trying to go back, I was really trying to get a hold of my time management. I'm trying to check through to clear my mistakes. It closed, and I'll just do better next time, sir. That's just what it is.
Yeah, you better do better next time. I mean, because there's very few next times left now, right? We're almost towards the end here. We're almost towards the end here. I don't know. All right, okay. Very sad, I suppose, but life is sad. Life is good nonetheless. All right, I mean, in case you're interested in finding out who you want to ask, if there's certain parts of this thing that you don't understand, these are some of the people you can chat to try and find out how it is they manage to solve some of these problems. I mean, of course, the solutions will be uploaded into the Moodle, and then we'll go through these things on Sunday. But yeah, so our leaderboard, and I should mention here that the leaderboard sometimes, because of space, there are some names. These are ordered by grade and then finally by surnames in ascending order. So there's usually some people, a good number of people that will probably get the same mark, like a B or 60%, but they're not included here because they are way below here, right? So 9, 10, 11 up to, so there's still a couple of people that got, I think, 60s and Bs, but not as many as would have wanted, which is why we have this really pathetic picture here. You know, it's just, I mean, it's just 7 of them actually, if you think about it here. These are the people we're talking about. So just missed out a few of them, I guess. If we have, it's just 5. I mean, if we have 2 of them here, there's 5 missing here. Yeah, so I don't know. There's some things here. Yeah. Anyway, so like I said, we are meant to have class on Sunday. We can't have class on Saturday, apparently it's a holiday, right? Go to the museum, unwind, think about why you are failing. It would be better if you go to the museum, I assure you. You'll be able to reflect on your misgivings. It's good. And maybe you come up with a solution here. And this is where these people come in, right? What you should do, if I were you, I'd go to these people and ask, what strategy are you using, Patrick, right? What strategy are you using? Why is it that your name always appears there? You're doing something right. If you've noticed, there's some names here that are always popping up, right? They're always here on this leaderboard here. What that means is that they're doing something right. What you should do is reach out to them. Now, I did have some people here that I'd go to them and they weren't very friendly when I was a student myself. I was like, okay, that's fine, but I'll go to the others. But go there and ask them, right? Christabel, I see her name always popping up here. Teresa as well. If you're comfortable with the female folk because you're female, they're there. If you are comfortable with just interacting with males, they're there. Everybody's there. Now, I don't know if the other genders are here, but in Zambia, I think we only have 2 here. So this is the thing here. Ask them what strategy they are using so that perhaps you can experiment with that strategy and maybe hopefully start passing as well, right? So alternatively, we'll have class on Sunday. If not, an email will probably sent out on Saturday itself or maybe on Sunday itself. I do believe we'll have class. So, and then the quiz, you notice the quiz was we were supposed to have that quiz on Friday, I believe, but we've moved it to Tuesday because we were ideally supposed to have started this lecture series over the weekend, which we didn't do, right? So take note, quiz next week, Tuesday, on the 27th, right? It's going to be based on content covered in lecture series number 15, which is what we've started right now. All right. No, I don't think that the government will say Monday's a holiday. It's not a holiday, right? Okay. So the quiz again, right? So this is what we're going to cover Monday. And details of what sort of things are going to be in the quiz will be shared. It's likely we'll have 2 quizzes based on this particular lecture series, right? So I think depending on how far we'll go tomorrow, we'll be able to share with you what sort of content will be in the quiz. But ideally, what will be in the quiz will be what will be covered until tomorrow, essentially. We can tentatively say that. All right, so unless if there are any questions, I'm going to proceed and just do a brief introduction to this course and then try and see exactly how far we're going to go. Any thoughts so far? Questions, concerns, complaints?
So
yeah,
I also received a question. We were having a question saying test 2 is going to cover everything from the start, right? Or it's just for semester 2?
Yeah, but that information we shared, we said everything covered in the course, that will be covered in the course, with the exception of what was in class theory test number 1. Now, that's not to say that we will not sneak in a question that will have content that, like some little content or like the ideas underpinning what was covered in term 1. And it makes sense, right? Because what we're looking at is connected, right? Remember, we're peeling these onion layers one at a time. We're abstracting. We started off with the higher levels of abstraction, and then we're drilling down into the lower levels to understand how this computer works, right? So yeah, it's content covered in the course with exception of what was covered in term number 1. So in essence, just concentrate on what did not, or what was not covered in class theory test number 1. Can't remember which topic we ended at.
All right, sir.
Good.
So I have a complaint. I don't know if and some clarity.
Yeah, please complain, ask for clarity or clarification. This is what we want, right? We are almost towards the end. If you're not going to complain now, there'll be, I guess you'll never complain, right? I try here to make it easy for you to complain. And now I was taught by some people that were not as approachable as I make myself, you know? I'm putting myself on a pedestal here, I know. But I try here. And I'm hoping that you've gotten to a stage where you're free, right? You're free. It's a free world, I guess. It's a free country, right? Freedom of speech, apparently they call it. You're free to complain, to even shout at me if you want to. It's not like I'm not the person who have grudges and, you know, we must talk, right? We've gotten to a stage where we should have open dialogues. Please complain, seek clarity if you want to.
Yes, it's pertaining certain aspects of the quiz.
Okay.
There are certain answers that I provided.
All right.
Because mostly all the quizzes required a lot of calculations.
Okay.
In 16-bit representation, the way I was
Yes.
presenting my answers was every after 4-bit representation, I would space the answer. Like,
Yeah, no,
in
that issue, by the way, is this quiz number 13 or 14?
no, 14.
If it's quiz number 14 or if it's quiz number 13, I fixed that in quiz number 13. If it's in quiz
No,
number 13 and
the
you were
recent one.
marked wrong, like I know Anita is one of those people I'm supposed to respond to, please send me another reminder maybe tomorrow to say you haven't yet marked until I mark, right? If your spacing is not, it's not like we want you to provide the solutions exactly as they appear like so. You can space them if you want to. It's just that, you see, when you, the way the solutions are kind of like configured within the Moodle is a certain way, right? So if we notice that there's a person, for instance, we had people that had negative 2030 as an underbar, right? That's fine. We understand what you were trying to do, yeah? And we were able to reconfigure, right? But of course, we know there is a difference between a hyphen, a minus sign, an underbar, an en dash, and an em dash. These are all different things, right? So unfortunately, our solutions are configured with hyphens or minus signs, not an en dash, not an em dash, and not an underbar. But of course, if you tell us to say my solution was with an underbar, we shall configure it like we did, and then you'll be regraded. So just reach out to us, tell us to say this solution, this question, I provided my solution with, oh my God, I provided my solution with spaced out nibbles. Could you please look into that? And then Lighton will do this, right? It's a correct solution, right? Are there any other concerns?
Thank you. That's it, sir. The other is seen on the email.
Is there anything else? I don't know what this is happening, but I don't understand. I mean, I look at this and I'm thinking, really, these people are failing to. Why? What was so hard about this? This is a question that was, in fact, discussed in the lecture series, right? All you have to do is you play around with those formulas, right? 2n minus 1, you know, anyways, you go to the range and whatnot, but positive or negative 2n minus 1, minus 1, or positive or negative 2n minus 1, all the way up to positive 2n minus 1, you know, or negative 2n minus 1 minus 1, all the way up to positive 2n minus 1, right? You'll be able to figure out what this is here, right? And you can actually tell by looking at the magnitudes of the numbers here that this is, the positive number is 1 less than the negative number. So meaning that the 0 on the left side here, there's no negative 0. And if there's no negative 0, then you can easily figure out that it's 2's complement, and then you play around with the formula for 2's complement. Then you'll be able to find the n, right? It's effectively what you are doing here is solving for n using that formula. But hey, okay. I don't know what's happening here, but all right. So we start. If there are no complaints, do not despair. I mean, there's still hope. There's always hope in life, but do not rely on what they call the hope strategy. And I don't know if I've spoken to you about the hope strategy. Hope can be very dangerous, right? Study, right? Don't rely on hope. I hope I will pass. If you don't study, hope will be useless here. So our discussion of lecture series number 15, which is essentially data encoding, really is it's centered around us trying to understand exactly how a computer gets to encode the different types of data that we have. And you notice from the title slide here that our focus is going to be in trying to understand exactly how text, color, images, and sound get to be represented by a computer, right? Because remember that how a human being perceives, how a human being perceives data is different from how a computer perceives data, right? I mean, as a human being, you're looking at this slide and you're looking at the broad spectrum of data here, right? There's images embedded within this text, there's textual content, there are colors here. You can see that there's, blue, there's black, and the white background and whatnot. So we're trying to understand exactly how data is encoded, right? And our interest is from the perspective of the computer here. It turns out also that if you notice that the way this lecture is tagged is we're saying we're going to look at how text is encoded, how color is encoded, how images are encoded, and sound. The other types of data that you might be thinking about are derivations of what you're looking at here. And you sit there, oh, but light on, wait a minute, how is video encoded, for instance? Well, it turns out that video is a combination of audio or sound and moving pictures, right? Images, essentially, right? So what we're saying is we're interested in trying to understand how these fundamental building blocks of data get to be represented by a computer, right? This is why we have lecture series number 15, right? So this is what we're going to look at, and then towards the end we sneak in just to try and solidify our discussion of secondary storage. We sneak in this notion of data compression, right? So we look at reasons why we might want to compress data, right? For the most part, you're interested in conserving space, right? Because it turns out that space is a premium, especially as you generate increasing amounts of data on a regular basis, right, or routinely. You want to make sure that you effectively or efficiently store this data, right? One of the ways of doing that is to take advantage of compression. And I'm sure you've used zip utilities, right? Can you zip these files or something? Can you change the encoding of this from a high definition video to maybe a lower resolution video or something? You're compressing essentially. So we have a brief discussion of data compression here, right? I mean, this has become second nature here, but just to rub it in and to remind ourselves why we're having this conversation in the first place, there's a story we're telling. The story is from a perspective of a computer and what it does, right? Fundamentally, it keeps saying it takes in input, processes the input, presents the changed input as output, right? Which is effective information. Optionally, that output will be stored to persistent storage, secondary storage, or computer storage as they call it, right? Right, and so this is a picture here of what happens. So this applies to our discussion of these building blocks of data we're talking about, whether it's textual content, for instance, it goes through this cycle as well. Right, so fundamentally, right, it turns out that the building blocks, like I said, or the main types of data or categories of data that a computer gets to work with here is just text, colors, images, and sound, right? Irrespective of what sort of data you think about here. And usually text or content is usually represented using a combination of one or more characters, yeah? And the character usually is represented by a byte, right? So what we're saying here is that for us to create this textual content you're seeing on this slide, we have a combination of so many different characters here, COMP and whatnot, right? But this is best specific if you actually look at a full-blown text file or something, right? And we've done this before. If you remember, if I open this file, and I'm just going to zoom in briefly, and I type in, no, not Facebook, I'll type in ICT 1110. What we're saying is that this, if I save this file, right, I'm going to save it to persistent storage in my home directory. I'll call it text data encoding, TXT. Yeah, TXT, we discussed this, is just it's putative, it's just by convention to signal the fact that this file, to another human being who's going to read this file, say this file has textual content, right? Could have been, sometimes I create files with an extension of MD, for instance. I create a lot of Markdown. Like if you look at some of the things I have here, I'm not showcase to you some of the things I have, by the way, what I was doing earlier, these examination things here. This is all Markdown, right? But it's textual content, right? But it's just Markdown. Anyways, so I create this text file and I follow the convention, and I have an extension of TXT, right? Unlike Markdown, which has 2 characters in the extension, I follow through with the norm, right? What people expect, TXT. And the interesting thing that happens is if I go to my if I use my file manager, yes, if I go to my file manager and go to the location on this persistent storage device or storage medium where I've saved this file, which is in my home directory here, internal storage, and I zoom in briefly here, and I check the size. You notice that the size here, the 9B is 9 bytes. The 9 bytes corresponds to the size associated with each individual character in the file. So essentially, what this means is that not this. It's 9 bytes. There we go. What this means is that I expect, if this is a text file, I expect this text file to have 9 characters. It must have 9 characters. I guess in certain instances, depending on the sort of application you're using, it's possible that you have one more character, right? Usually the carriage return character, right? Going to the next line. So true to that, if I come here and I count here, I will have 1, 2, 3, 4, yes, space is a character, 5, 6, 7, 8, and the carriage return, which is 9. And which is why we have these 2 here. You see the new line, I'll save this, and then try and, I guess it's still 9 characters. There's still a carriage return, I guess, a line feed, I'm sure, a line feed character is still there. But this is the thing here, right? 9 bytes still. This is the thing here. So each one of these individual characters here, what we're saying is represented by a byte, right? And we said, if you remember our definition many lecture series ago, we said a byte is represented by 1, 2, 3, 4, 5, 6, 7, 8. This will come back, right? This is why I'm talking about this. A byte is equal to 8 bits, right? So effectively what we're saying by looking at this file here is we're saying if you have 8 characters, or 9 in this case, we have a total of, I mean, we can count the number of bits that we expect to use to represent the content of this file, right? So again, just to remind us that a text is usually represented by a contiguous stream of bytes, essentially, bytes that correspond to different characters. Now we have a discussion of text encoding here. You realize that this notion of the encoding scheme used comes into play here. Right? But for now, we can assume it's plain ASCII, right, which is used to represent this row, which is saying it's 8 bits, right, representing a byte. And then again, I mean, you have colors, right? Again, you have a series of bytes that typically represent the color intensity. And you see exactly how you have a representation of maybe grayscale, for instance, or black and white. You see how the bits get to be used to derive color. It turns out that, and we talk about this, but it turns out that this screen of yours that you look at, I'm just gonna go to an image here so that it's very clear, right? If you go to, it turns out that if you go to a nice image, I guess, like this, as you are zooming in, and I think you've seen this, if you pass through Manda Hill, those billboards, you can notice that there's pixelation, there's small little boxes that you can see, right? It turns out that each one of these, they're called pixels. And the pixels, there we go, they're appearing. I don't know if you can see these. I'm looking for, wow. I'm looking for something that has nice color. Like, I don't know who this person is, putting on a red, purple durag here. But you notice that as I'm zooming in, you see this pixelation that occurs here, these small little boxes. Can you see this? These are the things that are used to specify the intensity associated with this pixel, right? And so a combination of these many different things here is what will make up what we call an image. Oh, there's a photo, I got a photo of somebody. It's just bits here, right? But we explain exactly how that works very, very soon. Oh, sorry about that. Oops, I don't know what happened here. My cancel. Beautiful. All right. So we're saying there we go. We're saying colors and images as well, which you just say. You notice that an image is made up of nothing more than there are these pixels which are composed of different color intensities, right? So maybe if we take a photo of you guys, surprise, you're from Africa here, right? You have black hair, right? So your hair color, unless if you go to the salon or something, will probably be represented by the color black or something, right? So the same goes for sound. I mean, typically all there is here is you convert, usually you convert the waveform that is coming through from somebody speaking, like when Lighton speaks through the microphone, that waveform is transcoded into a representation that can easily be mapped onto the sound itself, right, using ones and zeros. And we discussed how that works as well. It turns out it's a simple concept. These are all simple concepts here. But just to mention here that you notice that all these fundamental building blocks of data are doing nothing more than using bits in different sort of ways, right? You're working with bits. And the reason you're working with bits is because this is how a computer perceives data. As far as a computer is concerned, whether it's sound, whether it's images, whether it's text, all it sees is these things here. And by the way, it will see a continuous stream of, oh, sorry, not 5 here. It will see a continuous, there's a continuous stream of these things. Jesus. There's a, sorry about that. Okay. There's a continuous stream of these things here. So a single file, right? If you have this large file, a computer will see that large file as being composed of a contiguous stream of ones and zeros. And remember, again, we're abstracting this idea of ones and zeros, right? It's a flow of electricity, essentially. So as far as the computer is concerned, this is what it sees. And depending on the application, software application you're using, it will be able to figure out to say, oh, this data is sound. So the sound is supposed to be interpreted in a certain way. Yeah? Again, don't worry, this will make sense very, very soon, I hope. I hope so. All right, so we start with our discussion of textual content here, which happens to be now, there's a disclaimer here, guys. This slide is saying textual content happens to be most commonly used data format. I'm saying not for long here, which is true, right? These days, everybody. Yes, hi.
Before textual content over there, like on the previous slide.
Yes.
On the previous slide, we don't have a unit representation for colors, like it's just a series of bits.
Yes, a series of bits. Sorry. I mean, so you will see that the series of bits is represented using there's a certain technique. I mean, so we'll introduce concepts of so-called bit depth, for instance, right? These bits are supposed to be represented in a certain way. Like for an RGB color, for instance, you're supposed to have a stream of bits. Maybe if you're using a bit depth of 888, for instance, maybe 16, or maybe even more, then you have each of those different strands, like red, blue, and green, being represented by a stream of bits. But we introduce these when we dive into how this is done. The same goes for sound, actually. There's a way in which sound is represented. And the way that sound is represented is determined by the application. The application that's going to be used to create the sound and play back the sound. All right, this is exciting. I always like this. This is probably one of the most fascinating. This is one of the topics I enjoy teaching because I think it helps put certain things into perspective. You're able to relate most of these things, right? Every day you're mindlessly right there liking posts on Facebook. Oh, photo, right? Somebody posted a photo. You like it. You're on Instagram. You're watching some short video. These days, I guess, is TikTok or whatnot, right? Or Snapchat, is it, what's that, Snapchat or, yeah. It turns out what you're doing is you are consuming either one of these different data, right, or derivation of this. So it could be video, sound, images, colors, or text, a combination of all these different things here. Good stuff. Right, so when it comes to character encoding here, what we're saying is computers typically represent text in the form of characters. And there's usually this thing we call a character encoding set, right? A character set that is used to represent the different characters that are going to be used. And this makes sense because if you are Japanese, you will likely not use the common character encoding scheme. Why? Because you have these strange characters that are far removed from the English alphabet, right? But if you're a person who is from Zambia, for instance, surprise, surprise, we don't have the language which has its own characters. We use the English alphabet to write, shame on us, right? To write words, right? In Nyanja, in Chichewa, in Chiwemba, in Silozi, in Ichitonga, right? We use the English alphabet, yeah? So it turns out that you use a particular encoding scheme, right? Some popular encoding schemes include ASCII, right, or Unicode. And depending on the type of encoding scheme that you use, the bit representation is different. So what we're saying here is if you're using ASCII, for instance, each individual character, A through Z, including numbers, I guess, 1 through 0 through 9, will be represented using 8-bit representation. So you have a stream of 8 bits being used to represent those characters. If you use, I guess, the increasingly popular encoding scheme like Unicode, for instance, you start playing around with a different bit representation. In this case, it's like 16-bit representation. And we have some examples here. Don't worry, this will make sense very, very soon. But I just thought we'd start with one of the most, I guess it's one of the earliest encoding schemes, which is ASCII. Yeah, it's still used to a certain extent, I suppose. And most of the literature that you will find online will usually introduce you to this idea of data encoding using ASCII encoding scheme, because it's a lot easier for you to understand what you're working with. All right. No one will ask you what the acronym ASCII stands for, but in case you're wondering, it's American Standard Code for Information Interchange. Maybe they'll ask you in EDU 1020, but not in 1110. So ideally, this encoding scheme uses 8-bit representation, right, to represent each character. And if you think about it, if you remember again, think here. We said the number of things that you can represent with n-bit representation is equal to 2 to the power n. So if we're saying we have 8-bit representation, then we know that we can represent 2 to the power n of whatever character encoding we are using. So what we're saying is for ASCII, we can represent a total of 2 to the power n characters, right? 2 to the power n, which is 8, 256 characters. A, B, C, D, E, F, G, remember that, up to Z. Not only that, if you think about it, when you are writing, they will teach you maybe if your language is minor, use a comma, semicolon, underbar, minus sign, en dash, right? What's that? Tilde sign, exclamation mark, at sign, hash, dollar sign. These are all, a percentage sign. These are all part of the ASCII encoding scheme. And each one of these things here is represented using 8 bits, is what we're saying here. Do you understand this? What else is there? I don't know. A lot of things, I guess. Oh, it's an apostrophe, double quote, single quote. By the way, there's a difference between backquote or backtick and single quote, right? So all of these things are represented using 8 bits. And collectively, this including A2, here's where it gets really interesting. All of these special characters that you use on your keyboard, your English keyboard here, including A to Z and A, uppercase A to uppercase Z, these are represented using different bit combinations. So effectively, when you look at the alphabet A to Z, you're saying it's 26 by 2 because uppercase characters and lowercase characters must be represented using different bit combinations. They're different things. Lowercase a is not equal to uppercase A. Ideally, this is what we're saying. Do you understand this? So we're saying these 256 characters are a combination of numbers, and you can see them here, right? A space, exclamation mark, double quote, hash or pound sign, dollar sign, parentheses, I forgot this, parentheses, commas, and the numbers. You see the computer, including a full colon here. A computer has no knowledge of what 0 is. It doesn't know what 0 is. If you're using the ASCII encoding scheme, 0, what do you think 0 is? What is 0? No, you're there, I can see. What is 0? How can we represent 0 using 8-bit representation using ASCII encoding scheme?
Meaning we're going to avoid zeros. Huh?
Okay, 1, 2, 3, 4, 5, 6, 7, 8. And this makes logical sense, right? But surprise, surprise, there is a mapping, there is a table. Everything in computing is putative, by the way. The vast majority of things are putative, they are agreed. If you look at our table, 0 is represented by hexadecimal number. Can you see this? Decimal number 48 or hexadecimal number 30. So in fact, a 0 as far as the computer is concerned, if you're using ASCII encoding scheme, a 0 is hexadecimal 30, which is, we're going to do this instead, but a 0 is hexadecimal 30 hex into, what do you call this? 30 hex into, 30 hex into binary. What is that? Calculator, right?
30 times what? 30
Right,
times
so
16 to the power 1.
Beautiful. So whatever. So what we're saying is the computer sees a 0 as this. Now remember, we're saying ASCII uses 8-bit representation. This is 1, 2, 3, 4, 5, 6, 7, 8. So effectively, what we are saying is a computer is expected to see this 0, 0, 1, 1, 0. Whenever you see this pattern and you're using a computer software that is used to read text, what a computer will interpret it as is this. And this makes sense because when you open an application and you want to view encoded data and it's a 0, what a computer will do is it will print out, it will represent this stream of zeros as a 0 so that you see it as a 0. And it turns out that really, guys, you can see these things. Look at this. You see this ICT 1110, you see this file? I'm going to use my hex dump editor, right? Octeta. I love Octeta myself. I don't know about you, but okay, Octeta. I'm going to use this and I will open up this file. Observe. I will open up that file, the text file, which is in my home directory that we just created. And if you follow through with the encoding here, Jesus, view this using, sorry about that. View this using, I want it encoded using binary, I guess. Where is that thing here? I don't know if it's, I don't know where it is, but oh man, I'm trying to, I want to view this. I haven't used this thing in a long time. I'm trying to view this using show characters, values and characters. Oh, there we go. So value encoding, and then we say binary. Observe, right? If you pay particular attention to this, if we are saying each one of these streams of 8 zeros here, 8, there are 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. The last one is a carriage return. If you look at this stream of zeros here, where there's a blinking thing here, you notice that it's 0, 0, it's 0, 0, 1, 1, and then 4 zeros. 0, 0, 1, 1, and then 4 zeros. 1, 2, 3, 4. That's a 0. The last part here is a line feed. And in fact, you can check what this line feed is by just going to your calculator and just check what is the equivalent of 1010 in hex. It's an A. So you go to your ASCII table, you try and check. Is there an A here? Let me just check. It's supposed to be 2 things represented. It's not an A, sorry. You go to your hex editor and then you say, it's not an A, sorry. You come here, it's going to have to be 101, 101, 0, and 00 here. Right, so if you convert this, it's going to be, let's see if we can find this on the hex editor here. I wonder where this is. But ideally, it's supposed to be a line feed. Let me just see if we can find an ASCII table. That's ASCII table, not just a snapshot there, ASCII table. ASCIItable.com. Please use that, I guess. And I should probably share this with you also. Beautiful. Please use this ASCII table here. So if we go back to this ASCII table here and try and check this pattern, I'm looking for the pattern towards the end here. 4 zeros and then 1010, right? I hope this ASCII table has a binary mapper. No, okay. So what I will do is I will say 00000, let's start, and then 1, so 0000, 0, and then 1010, 1010. The hex is an A. I'm looking for, can anyone see that? I'm just looking for a line feed. I'm looking for a line feed character. I was trying to see if I could find the line feed character here. I can't seem to find it. I don't know if anyone can see any line feed characters here. That conforms to that thing that I just showcased. You know?
An A.
No, not an A. What we have is it's not an A. We have 1010. It's not an A. It's supposed to be 0. This is 0. Anyway, I was hoping we could find. This is weird. I was hoping we could find this line feed. And this is probably, I can't search through this, which is a bit weird here.
Sir, is line feed indicated as LF or something?
Well, yeah, it should be, I suppose. It's either it's a carriage return, so CR or line feed. Where is LF? Is it one?
It's
or...
in the first column, number
What's
10.
the number 10? Oh, beautiful. So you notice that, yeah, so it's because it's 0A, it's just A, right? So if you notice this thing here, 0, 0, it's 0A. It's just A. It's 1010. It's just A here, line feed character. So you can see here that this is a line feed character. And then if you look at 0000001 here, you notice that this maps onto, I guess you just convert. It's the same thing we were doing, right? Where you're converting the nibbles into the equivalent hex equivalent. And this is a 0 here. If you look up a 0 on here, if you look up the number 0, and this can be a bit confusing here, it's a number 0, pay particular attention to the character column. What you're looking for is where you have numbers. So it's from here. I don't know if you can, where we have 48 here. 0 is represented by, in hex, it's 30. What is 30? If you look at this, 1, 2, 3, 4, the nibble 1, 2, 3, 4 is 0. 0, 0, 1, 1 is 2 plus 1, which is 3. So 30, right? Okay. Do you understand this? I want to pause here. We'll continue our conversation tomorrow. Think things through.
I have a question.
Yes.
Why is it that 0 is represented as 0011
It's
and the 4 zeros
putative.
instead of 8 zeros?
It's putative. You know what happens when these decisions are being made? There's a consortium, so-called people that will sit and decide things. And this is coming back once you start looking at, I guess, aspects of programming, especially in third year, web programming. There are these international bodies that will sit and dictate. They decide to say, these are the rules we're going to follow. If you look at a computer, everything is centered around a set of rules because all you do is pattern recognition. When you're doing that, you want to make sure that everybody is following through with the same rules. So the reason why it is like this is because people sat and said, this is what we're going to do. Probably a long time ago, like in the ASCII, if you look up the history of the ASCII encoding scheme here, you notice that it's been happening for quite some time now, I guess.
So under character encoding, we have to be acquainted with this table instead of the conversions that we were doing earlier on.
No, if you think about it, if you look at this ASCII table, right, a question can be flipped over and say what bit representation is used to represent an exclamation mark, for instance. And we've had these questions if you look at past exam questions, right? So if you're given an ASCII table like this, which doesn't have the equivalent bits, it's just telling you these are the hex and decimals, then you can easily come up with the stream of zeros that a computer will use to interpret what character it is, yeah? Like this. Oh, so
and I can't see your screen.
Oh, is that the case for everybody?
No, we can see.
Yeah, so you want to fix your computer or your phone here. So here's the thing, right? If you think about it, observe, I'm going to leave you with this, right? And I know, I mean, it will make sense very, very soon, I promise. But I'm going to leave you with this. Observe. Now, this is me. This is a computer, right? This is what a computer sees. This is what a human being like Lighten sees, right? You come here. I'm seeing this. Computer sees this, right? Character encoding. Why is this important? Because a computer perceives this data that's encoded in a completely different way from a human being. In as much as a human being, somebody like you who's being trained how to interpret these things will be able to understand, to say, okay, if this is ASCII, then I know that this, you can easily figure out what this is, but it's much easier for the average person to just figure out what this data is encoded as by looking at this rather than this. A computer doesn't know what this is. It knows what this is. I'll see you when you see me, which is, I guess, day after tomorrow, early in the morning. Cheers. Thank you.
Thank you, sir. Patrick,